Thank you, everyone, for joining today. We appreciate your time as always. So as Pete said, we're going to go through a BK13 kind of refresh, and then there's also, which I think is more of the star of the BK13 talk today, is our BK13H series, and we'll get into that. But BK13, it's similar to a lot of the other Hirose BM products. It is a Hirose Korea-made product. It's 0.35 pitch, it's 0.6 height on it, the width 1.9 millimeters, and they're going to be used in like very narrow confine applications with FPC and FPC to board type connectors. It does do a high current, 5 amps off of the power. Given the size of the connector, it's actually pretty impressive. Part of the benefit to this is that the customer can get signal and power into the connector, so it kind of saves board space, one, because you can get one connector doing it instead of having two doing one power and then one for signal on it. It kind of combines it into one unit here. They also save money because they don't have to buy another connector. It does have a fully armored design on that, and we'll get into this about how it's fully armored. Some of the ways the connector goes onto the board or the FPC, it's got a multi-point soldering point, so it adds extra grip to the board or the substrate material on there. The way it is molded is a little bit different. It's a different process or a different method than traditional board-to-board type connectors, and it's intricately molded. So it's going to kind of prevent any solder wicking from the reflow process. And we do have a variety of mating heights that are under development, and that's kind of what I want to touch on today. It's added to our typical micro board to FPC type connectors. You can see we have other ones like BM23, BM28, BM29s. And in addition, we got BK13C, which is kind of the standard product. And then in development right now, we've got BK13H. So one of the things Hirose is hoping that BK13H is going to be another really great connector for Hirose, much like DF40 is. And DF40 is probably one of the top selling board-to-board connectors in the company or for Hirose. I think since its release date, I want to say maybe back 2010, maybe until 2008, we've sold almost 340 connectors on it. So the BK13, and the point here with BK13H version of it, it's going to add a kind of a very complementary side to the DF40 stuff. So customers who are using DF40 but they need power in our BK13H, we're going to be able to get that power type stuff. And so it's going to be a very complementary product to it, and we'll get into that. Basic dimensions, it's a very tiny connector. It's kind of really a mighty mite of connectors. Most of these will fit on a thumbnail, and you can see the mated condition is 0.6 height and it's only 1.9 wide, and I forget what let's see, this is going to be a 32 pin on there as we're showing. So it's for what it is and what it does, it kind of gets into a very small package on this. Again, like I had said earlier, the 5 contact or the power contacts on this save space. Typically, if it's a non-hybrid power type connector, the customer's got to devote signal pins to those power needs on it. So they typically have got to get something bigger in terms of pin-wise than that they need. Say if they need 40 and they're going to, 40 pin connector, then they're going to have to devote 5 pins to the power on each end of it, so it eats up 10, so they get their 30 signal. But if you go down to like the power BK13 with a 32 position and 2 position for power on it, you can kind of see the power or the space savings. It's 43% because there's dedicated power pins on this. So that's another benefit to the, we're actually freeing up board space with this. So the fully armored design prevents damage on it. So where I had said earlier, like a lot of connectors are older or more traditional wire connectors or board-to-board connectors. They use like say some of our DF12s or the older DF9, the connector was stitched into the housing on it, whereas stuff like BM and some of the other, or BK13 and some of the other BMs, they use like what they call insert molding. So the contacts are actually kind of made, or they're in a terminal type thing called a fret, and then they take that fret and they kind of place them in the mold, and then they basically shoot the resin around the connector onto it. And so instead of taking the contact and stitching it into the housing, they're actually putting the housing around the contact on it. So part of this is that in traditional stuff where there might not be any metal covering on the end of it, the BK13, as you can kind of see on the ant's eye view there, where it's protected on those ends with the fret or the contact. So there's really no plastic on plastic. It's literally getting metal on metal. So if somebody in the assembly process is a little bit maybe overzealous with it, or they're not, being particularly careful with it, the design of the fully armored is going to prevent any connector breakage. So it's going to be a benefit to the customer there's not going to be no design rework or wasted board on there from just, failure on it. So that's another key point to the BM or BK13. Kind of getting on here to the peeling strength. So we've got 3 points of contact on the bottom side of the connector, and they're all going to be hooked to the front. So there's not like one pad is only power. There would be 3 points there onto it. So each one of these points is going to add extra grip to the substrate material, and much like in, they're like they're like nails in carpentry. They're just extra points there to where it's going to be able to hold on to the board much better onto it. Getting onto the insert molded type stuff. So kind of in the cross section here, you can see all the green materials. Even though it's green, it's still the black material there. But as you can see where their cross section, that green resin material goes right up to the contact. So on the bottom side here, when it goes through reflow, if the solder wants to kind of wick up the terminal, it's not going to be able to do it because the resin is right there onto it. Whereas more in a traditional board to board, there might be some wiggle room there for that. Since it's stitched, there might be a place where you can kind of get that connector, or the flex or the solder can actually wick up the terminal. And it's the same way over here on the power contact side. So going on to the BK13H, and this is where I say this is kind of the star of the show today. So BK13H is, instead of being a regular BK13 where we just get into a 0.6 height, the BK13H is starting to get into different heights. So we got a 0.8, a 1 millimeter, 1.3, 1.5, and also a 2 millimeter height. While in this one square here where it says not recommended, even though there's a combination here for a 1.5 height with the top, the DP on the 10 millimeter or the 10 height, and also on the 0.5, it's not a very balanced connector, because on the DP side, it's getting into a really tall connector on one side. So even though it can be done, we're recommending that it not be done, just from a suitability of just mechanical type suitability onto it. It's going to be kind of really fragile. So if a customer needed to go to a 1.5, it would be much better to go with the 0.5 V10 down here on the left-hand corner, and the DP side on the 0.5 here up at the top onto it. So to give them that same 1.5 height. And this is something doing more outside work that I've found that we have had a lot of customers needing a DF40 into a power type height. So, and this is where I'm saying this is going to be a complementary product to DF40. So DF40 starts at 1.5 mated height, And then we do have a 2mm option height in DF40. So if the customer is needing both power and signal in a board-to-board connector, this BK13H is going to be the guy to look at to go kind of, promote in that instance there. So they're going to still get the pin count that they need for it, and they're also going to get the power into it. So it's going to satisfy that requirement of power into those different stack heights onto it. So some of the reason why we have different stack heights on this, as you can see here, where if you had other components on the board, there might be other stuff. It doesn't have to be another board-to-board connector or something with a flex on it. It could be, resistors or capacitors or whatever they have. If it's got to cross over that, it might be really difficult to reroute that flex on that one part. So it creates the lower connector is the stress is going to be applied to the flex circuit onto it because of the higher height connector. Whereas if we have the BK13H on this and you got the different heights on here, it can kind of get over, it can reach over. So the one of them could be a 0.8 height, and then you could use another 1mm combination of BK13H, and it will kind of get it up and above that, so you're not putting any stress on the connector. Typical applications are going to be smartphones, any wearable stuff, any of the BM or BK series are going to be good choices in wearables. Portable audio players, any laptops, portable gaming devices, even into more like industrial type applications where maybe you're getting very thin door locks someplace where they maybe have to get power to the display or something. One of these connectors is probably could be a good choice onto it. It's kind of a target, even though this is a target application, we haven't won this on yet, but this is a gaming console where each one of the blue arrows here shows an issue where we're getting stress because there's a slower connector and we're getting this type of where it's putting stress on one of the FPCs for it. Whereas if the company that this is for adopts our recommendation on BK13H, it would solve all of these blue arrows on the upper left hand here. So they would, they would have to use like a height 2, 3, 4, 5, and 6 on that, and to kind of get around so everything would be at the same height and we wouldn't get any stress to the flex circuit. So there is a quiz here, but since I did touch on some of it, we're just kind of going to go over this. So this kind of gets back to our earlier slide where it did show the slides of the different, BM23s, BM29s, BK13s. The correct order, there was smallest width to largest width, and this is something I should touch on too, is that the BK13C does not fit the same footprint as BK13H. I don't have a good answer, but I believe it's for the BK13H, maybe for the higher heights. They've made it a slightly wider footprint to give it more stability on the printed circuit board, but that's just kind of my interpretation of it or opinion of it. I'm not 100% sure. So correct order of smallest width to largest width on this is going to be BM29, BM28, and then BK13 on the 1.5, 1.7, and 1.9. Getting back to some of the stack heights on this, which is not included in the BK13 height variation plan. So there's primarily going to be, if you kind of add in maybe the 0.6, we've got maybe 5 on here or 6, but as far as the BK13H series, it is going to be the number 2. It's going to be 1.2 is not an option in those heights. So we're going to get the 0.8, the 1mm, the 1.3, 1.5, and the 2mm heights. And I just touched on this, which height variation has a different footprint. So it is going to be the 0.6 is going to have a different width on it versus the BK13H series. Just specifications here, although I do want to point out some of the variations on here in terms of pin count. So we get the 2 power pins down at the bottom and the variation, but we get, 6, 10, 12, 16, 24, 32, 40, and 60 on the signal stuff, and plus you get the 2 power at 5 amps on that. But kind of as a wrap up on it, I think the BK13, use that as a complementary product when customers are needing something that is like DF40, but they need power into it. And we've got the 1.5 and the 2 millimeter heights. It's possible that we might be able to do other heights on there. We would just have to look at volumes and how high it needs to go. So, but for those instances of when they need power and something the size of DF40, the BK13H is going to be a really good choice for those needs or designs. So other than that, are there any questions?
I'm looking at the chat box, Chris, and no questions in the chat box. So team, do you have any questions you want to ask Chris on the BK13 before we switch it over to Nathan?
Do all the BK 13 intermate, even though the footprint is different for the one? They still mate.
Was that one of the questions?
That was mine, sorry.
Oh, okay.
I believe the answer, Chris, from what you said yesterday is no, the BK13H does not intermate with the BK13. Is that true?
Oh, yeah, sorry. Maybe I didn't hear a portion of the question. Yes, correct. They're going to be wider on there. So I don't think the BK13, unless TAC is on here, but I'm pretty sure
Chris,
the BK13.
Chris, could
Yes,
you
TAC.
share the mating matrix again? That would explain the best, I believe.
Yeah, let me see if I can get back to that.
So basically, yes, we're preparing the kind of a matrix. 0.56 millimeter standard version, which is BK30C, and higher height BK13H does not mate.
Okay.
And yeah, mating matrix explains the kind of a visually the bit very well. So please refer to that. And
okay.
Yeah,
we'll have to send that out. I'm having trouble getting this back going again.
No problem, Chris.
Thank you.
all right.
And Scott, did we answer your question sufficiently, Scott?
Yeah, thank you.
Okay, you're welcome. Thanks, gentlemen.
Okay.
All right.
Thanks, everyone.
Yeah. So hello, everyone. My name is Nathan Moskal, and I'm a technical product specialist from the product management team at Hirose's Downers Grove headquarters. I am excited today to refresh your knowledge on our FX18 series, which is a pretty popular board-to-board that we have, as well as, like Pete said, introduce the FX18H, which is a new product that we are offering. These are high-speed, hybrid, and board-to-board connectors that are very popular in the industrial market space. So here is our agenda for today. First, I'm going to go through a little overview of the product, then hone in on some key feature points. Next, we're going to talk about some available variations of the FX18, including that NPI of the FX18H. And then we're going to discuss some target applications. And as always, there are going to be some questions sprinkled throughout. So pay attention and you can get those right. So the FX18H and 18 are 0.8 millimeter pitch high-speed board-to-board connectors. They support 16 gigabit per second PCIe Gen 4 transmission. They are available in a wide range of pin counts and orientations, including coplanar, right angle, and vertical orientations. They have very easy mating due to their large guideposts, which contain some multifunction contacts that I'm going to discuss more later. Overall, like I said, this product is ideal for the industrial space and has found many successes there in many different products. So the FX18 has a quote unquote hybrid design, is what we like to call it, that allow for a reduction in space used for your board-to-board connection, kind of like Chris showed with the BK13. Basically, the mating guideposts have 2 power pins or multifunction contacts in there that can handle 3 amps of current. The signal pins can handle 0.5 amps. So each one of those multifunction contact pairs replaces 6 signal pins, and there's 2 pairs, 1 on each end of the connector. So you're basically reducing the width of your FX18 by 4.8 millimeters at every pin count. The eagle-eyed among you might notice that there is actually a little different length on these two, and I will get into that in a second. That is a feature of this product. So here is our first question. I'll give you guys maybe 30 seconds to think of an answer. What is the maximum speed supported by the FX18 series? Is it 32 gigabits, 64 gigabit PAM4, 8 gigabits, 16 gigabits, or all of the above? So if you said 1, that is incorrect. That is double the rated speed. So is 2. 8 is less than the rated speed, and 16 gigabits per second is the speed that we rate this product to. So I mentioned that those MF contacts have different lengths. So you can see here that that enables them to have sequential mating. So the outer pair of the multifunction contacts will mate first. If you use those for ground, this enables a sort of shock-proof design because the power is going to connect last. So you have that ground contact, then second, the signal contacts, and then third, the inner power contact. Another feature of the mating of this connector is the effective mating length. So these can actually be sort of unmated up to 1 millimeter from whatever their recommended mating length is due to the long wipe length of those contacts. So the signal contacts wipe 2 millimeters, and then the multifunction contacts are plus minus 0.5 millimeter from that. So at this 1 millimeter unmating length, the inner of the 2 power contacts will be mated 0.5 millimeters, and that is fine based on our specification. So you do have a little wiggle room on the height of these and the width if it's a coplanar or right angle connection. Another note on mating is that these do support rotational mating. So as opposed to traditional board-to-board where you just have to stack them, directly onto each other, these can kind of have one edge connect first and then rotate in. So for an application like a PLC or some rack where you're going to be rotating the device in, the FX18 will support that, and this is a good feature that you should pitch when you're discussing this. Now we've reached our second question. This is about the current rating. So what is the current rating? Is it 3 amps for power, 0.5 amp for signal, 6 amps for power, 0.1 for signal, 5 for power, 0.5 for signal, or 8 for power and 0.3 for signal? So if you said number 1 or number 2, you'd actually be correct. So if you guys remember back to last month, if you were here, we talked about the FX23. That also has sort of power contacts on it. And we generally rate the contacts to the maximum overall power that you can put through the connector, which would be the 3 amps for power and a 0.5 amp for signal. However, if you have a customer that has a higher power need just for the power contacts, you can restrict the amperage on the signal contacts and get more power out of that. So you are able to double the power on the power contacts if the signals are restricted to 0.1 amps. And that's due to the overall temperature rise of the connector. As long as that stays below 30 degrees C is what we usually shoot for, then we're fine with that. And if you have a customer who has, say they need 5 amps for power and 0.2 for signal or something, we are happy to do the testing to find out if that is permissible to do. I mentioned that one of the strengths of this series is the wide variations. There's a lot of stack height ranges available for this connector. So you can see here it goes from 10 millimeters all the way up to 45 millimeters. So that's going to fill, a lot of the range that your customer might need between their boards. Once you get into some of the higher pin or stacking heights here, like 25 or 45, we actually have a 3-piece connection for this. So there's an interposer that basically extends the receptacle. So you'll push that in on the receptacle side, it'll mate, and then it'll lock. So it won't remove if you unmate the whole thing. And then it basically, you have a taller receptacle for some of those taller heights. Here is our final question. So which of the following are benefits of the FX18 series? Is it power and signal in one connector, hybrid connection, automotive grade, EMI shielding, many variations, or all of the above? So if you said number 1, that is correct. Number 2 is not correct. The FX18 is not automotive grade. Like I said, if you were here last month, we talked about the FX23. That is an automotive grade product. So you can pitch that if someone is interested in an automotive application or just needs, higher vibration and shock resistance. Does not have EMI shielding. Again, if they need that though, we do offer products that have that. The KP27F has shielding built in, and it does have many variations. So that is the end of the FX18 section of this, aside from the applications. So now we're going to talk about the FX18H. So there is a specification from Intel called the Open Pluggable Specification that is designed for digital signage like TVs and flat panel monitors, where basically you can slot these big modules into the back of the device to provide additional computing power. And it sort of streamlines the design side for these display manufacturers. And the FX18H was created to be a part of this OPS standard. It is intermatable with FX18. Currently, it is only available in a coplanar mating style, though, unlike the stacking and right angle that the FX18 is available in. This product does, however, have a slightly different contact design that allows us to rate it up to 125C. It also adds USB support, which is a part of the OPS standard. So here's an example of what one of these modules would look like. In the diagram here, number 12 on the bottom left of that picture is the FX18. And this product, like I said, will kind of slot into the back of a device to give it more functionality, more ports. Specifically, adding the FX18H was a part of the OPS Plus standard, which added 4K DisplayPort and that PCIe Gen 4 capability to these modules. All of the OPS modules are of the same size. So if you have a customer that's designing this, they have a form factor that they're restricted to, and the FX18 is a part of that. So if you are pitching to a digital signage customer, they're probably already aware of this, but if not, if someone does need a 125C coplanar connection for board-to-board, this is also a good product aside from these OPS products. Here are some of the applications that the FX18 has kind of found a home in: industrial machinery, medical equipment, sort of servers, PLCs. Again, it's a board-to-board connector, so this is going to be for slightly larger products where you have multiple boards. But due to its power contacts and a wide variety of options, this is a really great product for anyone who's looking for a board-to-board connector, and you should consider it as an option for them and see what they think. That is all from me, and I think that's all we have today. So thank you guys.